All right, let's dive right in. Today, we are tackling one of JavaScript's most powerful and, let's be honest, sometimes confusing features, closures. It's a concept that can feel a little bit like magic at first, but trust me, once you get it, it unlocks a whole new way of thinking about your code.
The whole idea really comes down to this one kind of mysterious question. How on earth can a function remember things, like variables, long after the function that created it has already finished running and disappeared? It feels like it shouldn't be possible, right? Well, that's the puzzle we're going to solve today.
So, to get started, take a look at this piece of code. It's a function I'm calling make_calculator. You can think of it like a tiny factory. Every single time you call it, it spits out a brand new calculator object, complete with its own add and multiply methods. But here's where it gets weird. Each calculator it makes seems to have its own private, hidden memory. Let me show you what I mean.
Okay, first up, a curious piece of code. We're going to see this puzzle in action, and you'll see why it feels like it's totally breaking the rules of how we think functions are supposed to work.
So here's our little factory at work. First we call it, and we create first calculator. Then we call it again to make a completely separate second calculator. Now watch. We add 3 to the first one, and its internal number n becomes 3. But then, when we add 400 to the second calculator, it doesn't mess with the first one at all. Its own n becomes 400. They're totally independent. So how does each one remember its own personal value of n, even though the make calculator function that created them finished its job ages ago?
To wrap our heads around this, let's try a simple metaphor before we get all technical. We'll call it the backpack analogy, and it's a fantastic, really intuitive way to get a feel for what's happening under the hood.
Okay, think of it like this. It's a kind of parent-child secret. A child function will never ever forget the secrets, the variables, that were shared with it by its parent function, even long after that parent is gone. It's like the inner function has this special bond with the place it was born.
So let's walk through this story. Step 1, a parent function runs, and it creates a secret variable. Step 2, inside that parent, it also creates a little child function. Step 3, now this child function has access to that secret from its parent. Step 4, the parent finishes its work, it's done, and it returns the child function. So for step 5, this child function is now out in the world, all on its own, but it still remembers the secret. It's like the parent packed a little backpack for the child filled with all the necessary supplies, all those variables, before sending it out.
The backpack analogy is a great starting point, for sure. But what's actually happening inside the JavaScript engine? It's time to connect that metaphor to the technical reality of how this all works. Let's do it. So here it is, the official definition you'll find out there. A closure isn't just the function itself. It's a pairing of two things, the function plus a reference back to its outer scope. And that outer scope has a fancy name. It's lexical environment. Lexical just means related to the way that words are written in the code. So the function basically carries a permanent link to the environment where it was created.
This code shows that perfectly. The inner function is created inside of foo. So when foo returns inner, that function doesn't just come out by itself. Nope. It brings that backpack with it. And inside is a live reference to that secret variable. We say it has closed over the secret.
And this whole idea leads to some really key concepts. Every function gets created with that link to its outer scope, which forms something called a scope chain. This is what allows for that awesome data hiding, just like in our calculator example. It literally means the outer variables are kept alive in memory just for that function. And this is super important, you're going to see why in a minute. The closure holds a live reference to those variables, not just a static copy of their value.
Okay, so this is all cool academically, but where do you actually use this stuff? Let's go look at how this one concept builds into some really powerful patterns that developers use every single day. Let's look at closures in the wild.
I mean, that's the million-dollar question, right? We're starting to get the how, but what about the why? What are closures actually good for in the real world in the code we write every day?
Well, the first huge use case is creating private state. You got to remember, before JavaScript got the class keyword with its private fields, closures were the way to do this. That variable n in our calculator, it's a perfect example. It's a private variable that only the add and multiply functions can see or touch. Nothing from the outside can mess with it directly. That gives us real, true encapsulation.
Another massive one is in event handling. Let's say you've got a button, and you want to keep track of how many times it's been clicked. With a closure, you can create a counter variable that is totally private to that button's click handler. It keeps the state all nice and contained and avoids just throwing extra variables into the global scope where they can cause all sorts of problems.
And if you're exploring the world of functional programming, closures are the engine that drives really powerful patterns like currying. That's where a function takes one argument and then returns a new function that remembers that first argument while it waits for the next one. It's definitely a more advanced technique, but it just goes to show you how fundamental and versatile closures really are.
All right, let's tackle a classic gotcha. For our last section, we're going to look at a puzzle that I swear almost every JavaScript developer runs into at some point. And it perfectly reveals a super crucial detail about how closures work.
So the setup is really simple. What happens when you try to create a bunch of different functions inside a standard for loop? You might expect one thing, but if you're not careful, you're going to get something completely different. Okay, look at this side by side. It's so revealing. On the left, using the old var keyword, we loop 3 times, pushing a new function into our array each time. But when we actually run those functions, they all print 3. Why? It's because all 3 functions created a closure over the exact same I variable. By the time we call them, the loop is long finished, and the final value of that one I is 3. Now look to the right. By just swapping var for let, it magically fixes the problem. That's because let is block scoped, so it creates a new separate I for each turn of the loop. Each function gets its own private I to close over.
And that little puzzle just hammers home the most important takeaway of all this. Closures capture the variable itself, not a snapshot of its value. They hold a live, breathing link back to that variable. This is that reference, not a copy idea we talked about earlier.
And all of this leads to a final, pretty powerful insight that kind of reframes this whole topic. You see, technically, in JavaScript, every single function is a closure. Yeah, even a simple function you write in the global scope is a closure because it has access to that global environment. This isn't some weird niche feature you have to opt into. It's a fundamental property of how functions work in the language, period.
So the mystery is solved. A function can remember its birthplace because it always carries that backpack, that live reference, back to its original scope. So now that you know their secret, the real question is, what powerful new patterns are you going to build? Thanks for joining me.